Alrighty, now let's finish example 2, part C and D. But before I continue, I just want to emphasize that you don't always have to use the rational zero theorem. Like for example, part A, we could have simply just factored by grouping. Okay, so just really quickly. Okay, as you can see, they both have like an x squared in common. So I take that out and then I get 4x plus 5. And over here, they have the negative 1, so I have 4x plus 5. Then this could equal to 4x plus 5, x squared minus 1. And then even more, 4x plus 5, and then x plus 1, x minus 1. Okay, and then you could have found the zeros that way. For A, the reason why I did it is just to show you guys the, just so we could apply the rational zero theorem. Okay, and also in part E, as we saw, like there was no rationals. Okay, but one thing that you could have checked at first is because you could have seen that you could have had a substitution y is equal to x squared. Okay, and you would have seen that it factored nicely. So look at those options first. Like for example, B, we would have done the zero rational theorem, okay, or rational zero theorem, because when you factor by grouping, so for B, I'm not going to rewrite it, okay, just to save time. But as you can see, 3x cubed minus 8x squared, it has x squared in common, so I have 3x minus 8. And then 2x plus 5, there's nothing in common. Okay, could not factor by grouping here because there is no common binomial. All right, since there was no common binomial, then the other option was to do synthetic division. But first we have to know which ones we can do. So use the rational zero theorem. Right? So let's look at letter C. Okay, I'm going to bring that down here. Okay, we have f of x is equal to 2x to the fourth plus 3x cubed minus 15x squared minus 32x minus 12. So I look at this, okay, can't do any simple substitutions. I can't factor by grouping, okay, so I'm going to use the rational zero theorem. So again, what is my a naught? Remember, it is always the constant, the term that has no x, so that's negative 12. And then I'm going to look for the highest degree, and luckily this was in descending order, so this is a fourth degree polynomial, and the a sub n, or a sub 4, is equal to 2. The coefficient is this. All right, so the factors of 12, now we have to list the factors. The factors of negative 12 is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay, I can put 1 because, 12, negative 12 divided by 1, or negative 1. It goes in nicely. 2 goes in, so it's 1 times 12, 2 times 6, and 3 times 4. Right? Those are all the factors of 12. And for 2, since 2 is a prime number, we just have to worry about two numbers. It's plus or minus 1 and plus or minus 2. So now we have to list what are the possible rational zeros. Oops. Okay, so again, I'm going to take remember, I'm going to take this, and I'm going to pair it with each of these, and then I'm going to continue that process. So I have plus or minus 1 over 1, plus or minus 1 over 2. Okay, that was the first a naught. And then now I'm going to do plus or minus 2 over 1, plus or minus 2 over 2. And I have plus or minus 3 over 1, plus or minus 3 over 2, then plus or minus 4 over 1, plus or minus 4 over 2. I'll just go down here. Plus or minus 6 over 1, plus or minus 6 over 2, and lastly, plus or minus 12 over 1, plus or minus 12 over 2. Okay, as you can see, a lot of options. However, not all of them are going to be unique. So, what are my unique rational zeros? Unique possible rational zeros. Okay, I have plus or minus 1, plus or minus 1/2, plus or minus 2. This 2 over 2, it's repeated, so I don't have to do that. Okay, so then I have plus or minus 3, plus or minus 3/2, plus or minus 4. Again, plus or minus 4 over 2, that's just 2. We already wrote that, so that's also, we don't have to rewrite that one. And I have plus or minus 6. Plus or minus 6 over 2 is plus or minus 3. Again, we already did that. And then just to, save some time, plus or minus 12 over 2, that is 6. And we also wrote that. We already wrote that. So I have plus or minus 12. Okay? So these are all the possible, the unique possible rational zeros. So not as big as this list, so thank goodness. Okay, we have less options. So now, what are we going to do with this? What we're going to do is we're going to now find our zeros. Okay. So because I already went over how you can plug in, going back to my example, we can do f of 1, okay, and then you can see what it equals, f of negative 1, etc. But because I did emphasize that, I do think it does take longer, okay, because once you know synthetic division, then it can go by fast, okay? Some of you probably see, because I, kind of get tired of explaining the steps, and I just kind of do it. So this one, so that's probably not good of me. So this one I will explain again how to do synthetic division, and then probably as we do examples, I'm going to go faster, right? So again, I'm going to write the coefficients. Luckily, this is in order, so I don't have to change anything. So I'm just going to write down the coefficients. So this is 2, 3, negative 15, negative 32, and negative 12. Okay, we're going to draw a horizontal line. Right, let me add more space here. Oops, not that much. Okay, and now let's solve. So remember, synthetic division, always bring down the 2. Right, so, and then 1 times 2, this is 2. Then we're going to add 3 plus 2 is 5. And then repeat the process. 5 times 1 is 5. Negative 15 plus 5 is negative 10. Negative 10 times 1 is negative 10. Negative 32 plus negative 10 is negative 42. Negative 42 times 1 is negative 42. Negative 12 plus negative 42 is negative 54. Okay, now, since it's not equal to 0, our remainder is not 0. What does this mean? This means 1 is not a 0 to our polynomial. Okay, so just if you want to do it this way, then you can say, if you found f of 1 instead, you'll have found it to be negative 54. Okay, maybe it should be a different color to show that it's not part of our solution. Okay, so now what I'm going to do is I'm going to try negative 1. Okay, so I have 2, 3, negative 15, negative 32, negative 12. Okay, so repeat the process. Okay. 4. Okay, this is what you get with negative 1. So I just, I want to emphasize, like when the examples we did today, this is pre-recorded, 1 second. Like for example, like 3 and negative 3 and then 1, negative 1, it just so happened that our remainders were the same, but it doesn't mean that it will be. Okay, so just because 1 wasn't a 0 doesn't necessarily mean that negative 1 wasn't a 0. Okay, so yeah, you still try it out. Okay, so again, what does this? So this means that negative 1 is not a 0. So again, if you just plugged it in, f of negative 1 would have been 4. Okay, so I'm now going to try I'm going to try 1/2. Okay. Let's see. Okay, you can try 1/2, but normally what I like to do, it's all up to you what you want to do. You can, technically you don't even have to follow this order if you don't want to, but I like to deal with whole numbers first. So I'm going to do 2, right? So then what do I? Yeah, what do I get? So again, I'm going to put 2, 3, negative 15, negative 32, negative 12, right? And then let's go. So this is 2, this is 4, 7, 14, negative 1, negative 2, negative 34, negative 68. So this is negative 80. Okay, so again, not a 0. So let's try negative 2. Right? So I have, again, 2, 3, negative 15, negative 32, negative 12. Okay, so then this is 2, this is negative 4, negative 1, 2, negative 13. This is 26. This is negative 6, this is 12, and this is 0. So yay! Okay, we found a 0. So this is a 0 to our polynomial. Okay, so keep that in mind. So you can circle it, you can write it to the side, whatever you want to do, right? But now, okay, so I'm going to write this in a different color because you don't have to write this. So what is this? This is, so we had a 4th degree polynomial, so this is going to be 2x cubed minus x squared minus 13x minus 6. Okay, this is plus 0 because it's the 0 over x plus 2, but we don't need to write that. Okay, so this is the new polynomial that we are dealing with. You don't have to write this, but what does this mean? Again, you can check to see, can I do factor by grouping? Okay, but you can't. So what I'm going to do is I'm going to continue using synthetic division. So just to answer your question, it's a possible question that might come up in your head. Some of you might think, do we have to redo the possible rational zeros? Luckily, we do not. Okay, we just still have to. You can, but that's just extra work. We can still use these. Okay, I'm going to do this in a different color just to show you that we're going to do. So we're away from the 2x to the 4th plus 3x cubed plus all of that, and we're just going to focus on the 2, negative 1, negative 13, and negative 6. What you could have done is you could have just pulled these numbers right away. Okay, you did not need to rewrite this. Okay. So luckily, one thing that's really nice about this actually is since 1 plus or minus 1 and 2, since they were not zeros to our original polynomial, it also means that it's not going to be a 0 to this one. Right? That was really bad. So what does this mean? This means that when we pick new zeros, we don't have to do this one anymore, and we don't have to do the positive one. However, there's some times where the zero has a multiplicity, like multiplicity more than 1. So what we normally do is we take this, when we use synthetic division, what we normally do is once we find that 0, we rewrite the coefficients, okay, but we still check negative 2, just in case it is a multiplicity, okay? So we're going to go, so this is 2, this is negative 4, negative 5, this is positive 10, negative 3, and this is a 6, okay? And we also get a 0 as a remainder. So, okay, this is actually really great, okay, just because you don't have to check as much, right? So what does this mean? This means that we have like an x plus 2 quantity squared. Okay, negative 2 is a 0 of multiplicity 2. So again, if I rewrite this, this is equal to 2x squared minus 5x minus 3. Right? So now what we can do is we can do a couple of things here. So we can either continue doing the synthetic division, or because we know how to solve quadratics, we spent a whole chapter solving quadratics, maybe a couple, that we should be pretty comfortable solving these. All right, so we can do one of two things. So we can either continue using synthetic division, so you can do 2, -5, -3. Again, I would test out -2 just in case it might be a multiplicity of 3. We don't know, right? And then you can test like the plus or minus 1/2, plus or minus 3, and so on and so forth. Okay. Again, you don't have to recheck what you have checked already. Right? But I will not do that. What we will do, okay, since it is a quadratic, I'm not going to do this. I'm going to do it this way. So we have f of x, and we know this is equal to x plus 2 quantity squared, and then we're left with 2x squared minus 5x minus 3. Okay, so we want to observe 2x squared minus 5x minus 3 equal to 0. Because remember, we want to find the roots. We want to find the zeros. Okay, and the first thing I'm going to do is I'm going to ask, are there two numbers that multiply to be -6 and add to be -5? Okay, in that case, there's -6 and 1. Okay. We can do factor by grouping. So, okay, I'll go ahead and do factor by grouping. Okay, you can also do this guess and check. So we have 2x and then x. So these are the only ones that are possible. Okay, and I know I have to have a plus or minus somewhere. I normally just put minus, and then I do these three, so like this. Okay, and then I just figure out which one has to be plus, which would be this one. Okay, so I can add a -5. But let me also do it this way for those of you that want to see how I get that. Okay, so remember, what does the AC method do? It pretty much tells us that we can find a new combination we can write B as. So -6x plus x, when I add it, I get -5x. So that's just another way of rewriting it. And I'm going to do factor by grouping. So I have 2x, and this is left with x minus 3. Okay, and over here I just have x minus 3. This is great because we have a common binomial, so this is just x minus 3. And then when I factor that out, I'm left with 2x plus 1. Remember, there's an invisible 1 right here. And as you can see, you get this. Right? So you can either guess and check, or you can factor by grouping. So this is x minus 3 is equal to 0, or 2x plus 1 is equal to 0. So then this is x is equal to 3, or x is equal to -1/2. Right, so what are my zeros? My zeros are -2. It has multiplicity 2, 3, and -1. Okay, with this, forgot to put my x equals, so I'll put it at the end. Right, so these are my zeros. Even more, just because I know you guys have assignments over this, if I was asking to write this as a product of linear factors, okay, and this would be x plus 2, x plus 2, okay. They wanted a product of linear factors, so we just write the x plus 2 twice, and this is x minus 3, 2x plus 1, okay, and this would have been product of linear factors. Alrighty, so now let's do letter C. Letter C, I have, oh geez, I already did C. Let's do D. We are given g of x is equal to 5x to the 4th minus 11x cubed minus 14x squared plus 5x plus 3. Okay, again, before we even consider finding the rational, using the rational zero theorem, I'm going to see, can I factor this in any way, like make my life easier. And then, so yeah, but can't do it, so I have x to the 4th, so, but I can't substitute anything, I can't factor by grouping, and we can't, yeah, and then it's not a quadratic, so let's use the rational zero theorem so we can try to find the zeros. So again, what is A naught? a naught is equal to 3. It is the constant. And then I can rewrite this as plus or minus 1 plus or minus 3. This is just a prime number, so I just have to deal with two numbers. Luckily, again, this is put in decreasing order. So this is a 4th degree polynomial, and my coefficient is 5. So, and again, 5 is prime, so I can write this as plus or minus 1 plus or minus 5. So what are my possible, I'm going to call it PRZ, possible rational zeros. Okay, this is going to be plus or minus 1 over 1, plus or minus 1 over 5, plus or minus 3 over 1, plus or minus 3 over 5. Okay, so if I simplify this, this is just plus or minus 1, plus or minus 1/5, plus or minus 3, plus or minus 3/5. Okay, and these are our possible rational zeros. Okay, so again, I will use synthetic division. So I have 1, and then so my coefficients are 5, negative 11, negative 14, 5, and 3. Okay, so this is 5, 5, negative 6, negative 20, negative 20, negative 15, negative 15, and this is negative 12. Okay, so again, so what does this mean? This 1 is not a 0. So now let's try negative 1. When I do that, so, okay, let me rewrite the coefficients. Okay, so this is 5, negative 16, 16, 2, negative 2, 3, negative 3, and yay, we get 0. So what does this mean? This means that 1, or negative 1 is a 0 to our polynomial. So what am I going to do now? So I don't have to check this 1 again, okay, but we will check negative 1 again just in case it has multiplicity. So this time what I'm going to do is I'm going to rewrite this one, okay, because I already have, so before I start, so what is this? This is, we have g of x, and we know this is equal to x plus 1, and then 5x cubed minus 16 x squared plus 2x plus 3. Okay, now what we're going to do is we're just going to focus on this part. Okay, so that's why I can just do negative 1, and then this is going to be 5, negative 16, 2, and 3. Okay, you could, actually, so you can, so you can still use this 5, negative 11, negative 14, 5, 3. Obviously, you can't do the negative 1 again because you know you're going to get 0. That doesn't tell you if it's a multiplicity or not. But you could still use the original one. However, it's just more common to, once we find a 0, we just reduce our problem. Okay? So, yeah, like why you don't have to do the multiplying and adding for one less term, which is great. Okay? Less time it'll take. Ugh, 1 second, sorry. Alright, so let's do this. So this is 5, negative 21, 21, 23, negative 23, and this is negative 20. Okay, so this is not a 0 to this polynomial right here. Okay, so what does that mean? That just means that g of x, that this negative 1 is just a 0 to g of x one time. It's not, it has multiplicity 1. Okay? So, let's continue. So, what else can I pick? We could do 1/5. I usually try to avoid the fractions. So I'm going to do 3. Okay? So again, I'm going to take this 5, negative 16, 2, and 3. Okay, and let's go. So this is 5, 15, negative 1, negative 3, negative 5, negative. Yep. So luckily, yeah, so 3 is a 0. Okay. So I just want to emphasize, sometimes it's just a lucky guess. Okay, it's not always going to happen this way. You sometimes have to do some guessing and checking. Okay, don't be discouraged. So what does this mean? This means that 3 is a 0 to our g of x. Okay, so if I rewrote this, okay, my g of x is equal to x plus 1, x minus 3, and then this is 5x squared minus x minus 1. All right? So again, you could still continue on, okay? At this point, I would probably actually redo the zero remainder, because then you would just have to deal with plus or minus 1 and plus or minus 1/5, but we already know about 1, so you just have to worry about the 1/5, as opposed to worrying about the -3 and then the plus or minus 3/5. Okay. But again, we already know how to solve quadratics, okay? So let's use the tools that we learned before. So I'm going to observe, okay, 5x squared minus x minus 1 is equal to 0. Okay. So I'm going to first ask myself, are there two numbers that multiply to be -5 and add to be -1? And the answer is no, right? So, because for 5, it's only 1 and 5, okay? Like, that would be 4, so you'd either have plus or minus 4. So that doesn't work. So we can either solve it using the quadratic formula, or we can complete the square. I know you guys are more than capable of using the quadratic formula, so I will complete the square. So remember the first thing, all the other times I've completed the square so far, I've had a to be 1, which is really convenient, but not the case today. So I'm going to divide everything by 5, so then I get x squared is minus 1/5 x minus 1/5 is equal to 0. Okay, so remember I divided everything by 5, and then I'm going to add this. So remember, before, like this one, since I'm letting this equal to 0, I can do it this way. But remember, there's also that, like, f of x is equal to 5x squared minus x minus 1. Okay, and then how you have to do everything on one side, right? So yeah, just be really careful with that. But this one we can do it because we're solving for the roots. Since we're solving for the roots, we want f of x, or in this case, g of x equal to 0. All right. So now what I'm going to do, so my b is equal to -1/2. So remember, oh, sorry, not 1/2, 1/5. So my b over 2, quantity squared, this is equal to -1/5 times 1/2 squared. Okay, you could do -1/5 divided by 2, okay, but it's equal to that. So this is equal to -1/10 squared, so this is going to be 1/100. Okay, so I'm going to add it to both sides. I'm going to keep my weights equal, my equation equal, so or balanced. And this 1/5 plus 1/100. Okay, so this, remember, so this is going to be the x plus b. In this case, b, or the plus b over 2. In this case, b over 2 is -1/10, so this is x minus 1/10, quantity squared. 1/5 plus 100, so I'm going to do, so this is 1/5, I'm going to do 20 over 100 plus 1/100. Okay, so this is x, okay, I won't skip steps. This is equal to 21 over 100. Keep going. This is by using the square root property, okay, not taking the square root of both sides, using the square root property, this is equal to that, plus or minus the square root of 21 over 100. Okay, so x is equal to 1/10 plus or minus, and then side note over here, okay, remember the square root of a over b is equal to the square root of a divided by the square root of b. So in this case, the square root of 21 over 100, this is equal to the square root of 21 over square root of 100. So this is square root of 21 over 10. Okay, so they both have a common denominator, so what I can do is I can just put plus 1 plus or minus square root of 21 over 10. All right, doesn't matter. Okay, so what does this tell us? So what are our zeros? Okay, it's x is equal to, you can go ahead and write this one, 1 plus or minus square root of 21 over 10. Okay, those are two zeros, remember two, so 1 plus and then the 1 minus. And then again, what do we find? We found that -1 and 3 are also zeros. Okay, since they all have multiplicity 1, I am not going to, we don't have to write multiplicity 1, right? So that is how you find zeros and their multiplicities, and this is when how you use synthetic division multiple times. Right. So again, so if you guys have any questions, feel free to email me, and hopefully I can answer them, or you can ask me on class on Monday. Right. So I'll see you guys then. Bye.